Good afternoon, everyone. Welcome to the TechGeek webinar. Thank you for joining the session today. The topic of today's webinar is Rise of Cognitive Computing in the Digital Era. It will be a 1-hour session with around 40 to 45 minutes for the presentation and the remaining 15 minutes for the question and answers. So if you have any questions, please send them to us using the Questions tab on the GoToWebinar control panel. I'm Sabah, the moderator of this session, and it gives me great pleasure to introduce you to our guest speaker, Ms. Seema Kumar, Country Leader, Developer, Ecosystems and Startups, IBM India and South Asia. Seema, as the leader audience engagement for the ecosystem business, leads the developers, startups, IT professionals, students, influencers, government and policy makers engagement and defines and owns the life cycle of relationships with them, representing IBM India across brands and disciplines. The work done by her team is focused on infusing IBM cognitive and cloud technologies to help developers propel their careers and tech startups to build scalable platforms to drive their business. So without any further delay, let me introduce you all to our guest speaker. Over to you, Seema.
Yeah. Thank you, Sabah, and thank you to the overall TechGeek team for providing me the opportunity to speak on this platform. And I'm really excited to share some of our thoughts and viewpoints in terms of the cognitive business, right? So let me directly dive into the presentation. And the talk today is going to be around the cognitive era, right? And today we see digital disruption, digital transformation across various businesses. And how does a cognitive, computing paradigm help you further propel your business as we, see disruption across various domains? So that's going to be the key of the talk, and I'm also going to talk about some of the key tools and APIs available for developers out there who are attending today, in terms of how anyone can actually go ahead and build their own cognitive app, right? So that's going to be also a focus of my presentation today. As Sabah said, I lead the overall ecosystem program for IBM India South Asia. And on a day-to-day basis, we work with the developers, the startups, and several other segments of the ecosystem in terms of, infusing the technology landscape, as well as driving the thought leadership in the cloud and cognitive space. I have also posted my Twitter handle in there, so in case anybody wants to reach out to me or any comments further, if we don't have time at the end of the talk, please feel free to reach out to me on my Twitter handle as well. So let me just then directly dive into the presentation. Okay, so many of us, or all of us, right, will recognize these disruptive companies out there, right? And it's a very exciting era, and it's a very exciting age that in which we live in, right? Where if we take, for example, the example of Uber, right? Uber is one of the largest taxi companies out there which owns no cars. It's purely on an aggregation model. So similarly, if you take the largest accommodation company, Airbnb, they really don't have any real estate. Again, Facebook, all of us are very, very familiar with how Facebook has impacted our lives. But if you come to think of it, it's one of the largest media companies that really does not own any of the content that is actually published on Facebook. So all of us contribute to that content, are active contributors, editors into one of the largest media companies in the globe. And the same is the case with Alibaba, right? It's the largest retailer in the globe. It really carries no inventory on its own, right? It's again an aggregator. So if you look at a lot of these examples, and several more which are closer home in India as well, which are similar to many of these organizations, it's about the power of technology in disrupting a traditional line of business in a very different way. And one thing that is common across the board is, across all of these, it is it is the customer experience that truly differentiates, right? So the ease with which you're able to interact, you're able to transact, and you're able to engage with the business provider as a customer, the entire experience has gone up to a whole new level, right? And thanks to the various technologies and tools that are available to us, it just gets even better in terms of the engagement and the interaction. Okay, so let me move on. So how is this disruption? How is this disruption possible, right? It is, and it wouldn't have been possible, say, 20, 30 years before today, right? And there are a few key factors that are enabling this disruption across the board. First and foremost, it's the power of the data, right? So if you look at it, the amount of data that is generated on a day-to-day basis is just phenomenal, right? And this includes data that you generate related to your customers, your business, which could be internal to you, as well as a lot of data that is out there in the open, right? In terms of social data, in terms of Twitter data, in terms of news, in terms of events, in terms of data released out of sensors, with the entire revolution around Internet of Things. It's just blowing up altogether, right? So, and it is predicted that the overall digital universe is going to go up to around 44 trillion in 2020. So, I mean, if you could actually see the data, you would just bump into it everywhere and anywhere, right? So that's how big it's going to be in terms of the quantum of data. The second key enabler has been in terms of APIs, right? Open APIs. So again, and some of these companies, right, like Uber and Facebook are very good examples of organizations who've used the API economy to their advantage, right? So you no longer talk about closed systems. You're talking about open systems with APIs that are exposed to the developer community, to other startups, to other partner businesses, so that you're able to engage, you're able to collaborate, and you're able to transact in a very seamless fashion. And that thereby is another key disruptive force that is fueling the digital transformation around there. So the API economy in itself is again projected to cross over $1 trillion in the next 1 year per se. The third key aspect is aspect of cognitive, right? And we'll talk a lot more about what in turn entails cognitive for us, right? As developers, as business application owners, but it is also seen that IDC predicts that almost 50% of the applications that are written in the future will have some form of cognitive capability infused into them. So it's no more going to be a nice to have or an after effect kind of a capability. We will see more and more cognitive systems coming in, and that thereby will fuel further disruption in the ecosystem. And across the board, the world is reinvented in code. So it's no better time than now to actually, be in the business of developing applications. So if you're a developer, if coding is your, is your hobby, is your day job, there can't be a better era than now, right? So the number of lines of code in a smartphone itself that you can see out there is mind-boggling, right? So even something as traditional as the automotive industry is embracing the power of connected systems, the power of Internet of Things, and a very basic car is going to have hundreds of thousands of lines of code as part of its overall architecture. So that's the second key shift, right? So the first one in terms of the three forces where data, APIs, and cognitive is going to fuel the digital revolution. And the second in terms of the vast amount of code that is being rewritten, right? The systems of yesterday are being rewritten, and a lot of that is going to be cognitive in the future. So these are two key aspects. in terms of how we will see cognitive, playing a very, very important role as we move on in the next few years in terms of disrupting the way we engage. Okay, so let's now look at a step back, right? So before we try to understand the future, right, of what is cognitive computing and the impact it will have on our lives, it's a good idea to also look back a little bit and understand it in the historical context, right? So to this date, right, there have been primarily two distinct eras of computing, right? The tabulating era and the programming era. Now, and then the cognitive era, we believe, is going to be the next one, the third one, and the most transformational phase in the history of computing, right, that we have seen up to date. So if you look back at the tabulating era, the early 1900s to the 1940s approximately, this was an era where computing actually started, and there was the birth of the computing that started, and there was a single purpose, right? It was more in terms of punch cards and mechanical systems where you would input data, store data, and you would receive an output, right? It's as basic as the calculator that you see today were some of the earliest examples of a computing device, right? And that's where it all started. And then we moved on to the programming era, and many of us, we would have started our careers in this era, right? Is where we shifted into more programmable based computing systems. So a typical model is where you have a series of if-then operations, you have loops, you have instructions coded into software. During this era is also when we saw the invention of the transistor, the Moore's law, further helping in doubling the capacity of the systems out there, the software out there, and thereby we saw a lot of good innovation right in the programming era, and everything that we today use on a day-to-day basis as a device, be it your computer, your laptop, your mobile device, is a programmable computer, right? So that's the second key era that we are at right now. And now when you look at the future, right, the cognitive era, there's no better time, right? And artificial intelligence is not something which has just come up today or yesterday. It's been around for a while. But in terms of a timing, right, this is the right time when a cognitive system makes the maximum sense, right? It's at a time when we are dealing with vast amounts of data, both structured and unstructured data. We are dealing with the requirements to scale through volume, requirements to automate in large scale, and thereby the advent of cognitive computing systems is very timely as we see it today. So, and we will talk about some of the examples that we see early on in terms of actually making this a mainstream technology. Okay, so the world's first cognitive system, right? And I'm sure many of you listening in today would know Watson, would have either heard of it or experienced it in some shape or form. So the Watson computer was very first introduced in a game show called Jeopardy in the United States. It debuted in February 2011. It was a result of a research, project within IBM, within the IBM research labs, where the system was trained with a series of, Wikipedia and a series of literature around the various topics that were typically posted on a Jeopardy talk show, right? And in the final season of the game, it went ahead and competed with the two human competitors, the finalists, and went ahead to win that particular game show, right? So this was how it all started. While it started, and the very first Watson out there, all it had was a Q&A service, right? The ability to understand an answer and post it as a question, and thereby attach a confidence score to it based on which it actually went ahead to win the show. From there, the Watson system has come a very, very long way, right? We have gone ahead and very initially started working with key industries. Again, the selection of industries out here initially has been typical domains that deal with a large amount of data, and where there is a need to gain insight out of that data, right, at scale. So healthcare was one of those early industries where we started working with the healthcare industry leaders in developing something called Watson for Oncology, which is today a solution available for treatment of cancer and cancer research. So coming back to cognitive, right? So what exactly is a cognitive system? And here I would ideally like to bust a little bit of the naysayers out there that sort of predict all gloom and doom with AI and cognitive replacing human beings in such a way that it totally becomes all automated and out of control. We believe cognitive systems will forge a brand new partnership between people and computers, right? So it's not just one versus the other. A cognitive system will have the capability to enhance, scale, and accelerate human expertise, right? So a lot of the work or a lot of the functions that are mostly repetitive in nature can be easily automated with cognitive systems, right? And as human beings, it only enables us to augment our intelligence by providing us with access to a far better knowledge repository, a far better understanding of our data to make informed decisions, right? So it basically, if you look at the first bullet point here, it basically helps democratize the entire innovation model by scaling the knowledge that is available, right? And let me put it in the context of an example, right? And I just mentioned Watson for Health a few minutes back, right? Today, cancer research is, as a topic on its own, is one of the most extensive and expansive topics out there, right? So as an oncologist, right, when you're actually working or trying to, make an assessment or provide an approach towards treatment, you will dip into your knowledge repository, right, which is based on your own experience, the research papers that you're exposed to, the availability of information that you may have in terms of the existing data repositories, programmable systems that are out there. But by attaching a cognitive system to that, right, you are able to look at pretty much a very large scale repository of knowledge, identifying patterns, identifying similar cases, right, and thereby helping you with recommendations, right, not necessarily replacing your analysis, but providing you with the right recommendations in possible approaches towards treatment, right? And that in turn is a very, very powerful aspect which is very transparent in nature, which is done at scale, and which can in fact impact the way we interact and do business in the future. So moving on, what exactly is a cognitive business, right? And how does it typically compare with a traditional programmable programming-based system, right? So a cognitive system, and in here you look at the verbs out here, has the ability to understand, reason, learn, and interact, right? It's pretty much mirroring what a human being can do, right? It has the ability to understand in terms of understanding images, understanding visual cues, understanding languages, natural languages, the context in which the language is used, as well as understanding a huge bunch of unstructured data. It could be audio, video, images, so on and so forth, just like how human beings do today. Secondly, it has the ability to reason, right? So what is the underlying concept, right? Understand it within the context, understand the intent, form a hypothesis, and thereby provide an inference, right? And pretty much most of these inferences will also be attached with a certain level of confidence. So the best part of a cognitive system is it continues to learn, right? So as we continue ingesting data, data points and outcomes, it continues to learn in terms of the inferences that it makes, continues to sharpen its understanding and expertise. So at the end of the day, it only gets better with time, right? Because it's a continuously learning system. Unlike a traditional rule-based system, which has pretty static outcomes, however as many number of times as you may be using it. And finally, a cognitive system will have the ability to interact, right? Interact with a human, interact with another system in a seamless manner, right? With the ability to converse, have a conversation, the ability to hear, understand, see, in a very natural way. And that is where we see the application of cognitive systems in robotics, for example, in a very relevant way in terms of assisting humans in their day-to-day jobs. Okay, so to summarize, cognitive is in nothing but a new partnership between human beings and technology, while the humans bring in key aspects of common sense, moral values, emotions, imagination, compassion, abstraction, etc. A cognitive system will augment the human capability by the ability to locate where the information is, where the knowledge is, understanding common patterns, understanding natural languages, continuously learning through machine learning algorithms, eliminating bias. Again, bias is another key thing, right, that all human beings come up with, right? So you can actually train a cognitive system to remove the biases, which is very difficult to do in otherwise, human-only systems, and with endless capacity. So Watson never tires, right? Watson doesn't sleep. Watson doesn't need to go for a holiday, right? So those are some of the things that augment a human intelligence from a cognitive system perspective. Okay, so that was the stage setting on cognitive and what are the possibilities and what it means for us as we build our cognitive systems for the future. Now let me make it a little bit more real, right? In terms of how will you build with Watson, or rather what will you build with Watson, right? And is it something that is reserved for the research labs, reserved for people with very deep understanding of AI and artificial intelligence and machine learning and deep learning algorithms, or is it something that one can use, right, to infuse a little bit of cognitive capability into your day-to-day applications, thereby making them smarter, better, and more engaged with your end customers? So that's what we will look at in the remaining part of this presentation, right? So you will find something called a Watson Developer Cloud, and at the end of the presentation, I've included the links to the Watson Developer Cloud. So today, if you look at the usage of the APIs that are part of Watson Developer Cloud, we have over 100 companies who are either selling products or using some of the APIs from the Watson Developer Cloud. We have most of our clients, right, are also using Watson in some shape or form. We have over 80,000 developers who are using the Watson tools through Bluemix. It's being used across the various countries, across different industries, and exponential growth, right, in terms of creation over the past few years. Now, how is Watson Developer Cloud offered to a developer, right? So you have the option of using these APIs for free on a Watson Developer Cloud instance on Bluemix. So IBM Bluemix is our platform as a service offering. And the Bluemix platform, apart from the Watson APIs, also offers a whole bunch of other APIs, right, including the Watson IoT APIs. You can even do a very basic, web app development or a mobile app development using the boilerplate code, using the containers. Bluemix is based on Cloud Foundry. It supports most of the open programming languages out there, the open platforms out there. So it's pretty much a developer's playground. So in addition to all the other cool stuff that's there for a developer, you will also have access to a whole bunch of cognitive capabilities offered as Watson APIs on Bluemix, right? You could also download SDKs across the various platforms. So you have Node, Java, Python, iOS, and Unity SDKs that you can download to start building with Watson APIs. And this is pretty much where we see a lot of our developers starting off with Watson, which is again available for developers as a trial to begin with, and towards the end of the presentation I'll share a few examples of few organizations who've used some of these APIs to build their business ideas. Okay, so a quick preview into some of the Watson APIs. So there are over 50 capabilities that are exposed as APIs in the Watson Developer Cloud. Most of the capabilities around speech, vision, language, and data are included in these. So here in this slide you can actually see a listing of the various APIs that are available. Right, so from a language perspective, you have the natural language classifier, language translation service. You have, from a data perspective, you have a document conversion service that can be used to, understand the data within a particular document better. You have visual recognition APIs, you have speech-to-text, text-to-speech APIs, you have face detection APIs, so on and so forth. So the list goes on and on. Right, and we do see several use cases and instances where one or more combinations of these APIs can be used to infuse cognitive capability into your application. And the key thing is, again, right, when you're developing an app or you're developing a core solution, you really need not do the deep plumbing in terms of writing those, say, NLP, algorithms, when you have the access to the APIs that are trained to do exactly that, and you can continue focusing on what is the core business problem that you are trying to solve, right? So thereby it frees up time and effort from a programming perspective as you try to build some of these capabilities into applications. Okay, so I've taken a few examples here just to make it real, right? So the Watson Conversation Service, right? And most of you may be familiar with bots, right? And bots are virtual agents. So today, pretty much from a digital standpoint, right? We all prefer to chat rather than talk to somebody on the phone or see somebody face to face. I think especially the millennial generation prefers to just chat with a bot or an agent out there, right? So and the use cases can span multiple industries, multiple applications. So how do you write a chatbot, right? The conversation service helps you with just that, right? It provides you with an API for developers to build a chatbot from scratch, right? And thereby for any of the channels, right? Be it a mobile channel, a web channel, or even an IoT channel, you can actually provide a conversational experience to your end customer by using the Watson Conversation Service. The Watson Conversation Service picks up few of the key APIs, the underlying APIs that you saw in the previous chart, say the NLP API, and the dialogue related APIs, to create a conversation service. It has the tools, it has a dialogue builder that helps you. So depending on the domain for which you're building the service, your SMEs can actually construct the various conversational or the dialogue flows for these virtual agents, and thereby creating a seamless experience to actually have a dialogue with the chatbot. So if you go back to the Watson Developer Cloud, you will see a lot of help out there. There are code samples, there are SDKs, as well as if you want to further augment the basic conversation service with additional use cases such as speech and empathy, you could add in some of those, right? So you can add in a tone analyzer to understand the tone of speech, right? So on and so forth. So, And let me just take you through an example, right? And in this picture, you actually see one of our robots. This is at one of the leading hotel chains at the Hilton, where we have a concierge service, right? So the robot acts as a robo concierge. Again, it has the Watson conversation service running inside within it, and it's an automated concierge, right? So typical hotel front desk concierge related queries can be answered by this robot 24/7, right? So that's one example, and let me just get in deeper with a few deeper examples here, right? Okay, so you see this, right? And this is what I'm saying. I'm frustrated. I haven't been able to log into your online billing system, right? So this is what I'm typing in as your customer. So what does this mean, right? What is the intent behind this statement, right? Am I saying anything specific? How do I understand the underlying intent and thereby convert it into action? Okay, so understanding the intent. So what could be the intent? So a conversation API basically uses the deep learning algorithm to derive the intent, right? Again, you must know, right, the Watson instance has been trained with a lot of data, especially the Wikipedia data, for example, to understand language and concepts. And over time, as you feed in more data, both structured and unstructured data, it's going to train itself to be better. The intent could be one of the following, right? It's either that I'm frustrated because I forgot my password, or I'm not able to log in, so maybe I need to create a new password. I'm having some trouble with the site and hence I'm not able to log in. So these are the various intent maps that it does internally, and thereby it comes up with the conclusion that the intent of that statement was actually to do a password reset because I'm not able to get into the website. I'm not able to log into the site. You can also extract other information related to the question, right? So we have the intent here, which is a password reset. What are the entities? The entity is the online billing system. So where am I not able to log into? I'm not able to log into the, so that is the entity extraction part from the natural language classifier. And then you're also identifying the tone. So how exactly are we identifying the tone? So the fact that I'm saying I'm frustrated is showcasing a tone of anger. So the Watson tone analyzer sort of can be used to actually detect the emotional tone of the sentence over here. And what is the context? So the data surrounding it puts it in context as to who is asking it, through which channel they are asking it. He is asking it, I mean, he's sort of typing it through a mobile device, and hence there is some, specific action I need to take for this particular requirement. So that was just a very small example of how natural language classifiers along with the conversation service can be used to solve a lot of the commonly occurring problems, right, that can be trained with a virtual agent out there for your given business, and sort of answer those questions. In fact, I must a small digression here. I must share a very interesting use case, right, which is a real use case out here with one of the leading universities in the US, right? So one of the professors actually for the summer program, he created a Watson-based chatbot, right? So one of the agents in his conversation service was enabled by Watson. So in the summer, there are students who typically go out for internships, and they're all assisted by a teaching assistant, and they would interact with the teaching assistant through these chat services. So while there were 5 human teaching assistants, one of them was a bot, and the students did not really know. And through the summer, one of them, right, would be an automated chatbot powered by Watson. And the way the Watson chatbot would surface and answer a given question would be when, based on the training data and based on what it knew, when its confidence score was about 95%, right? So whenever it was fairly sure that this is what I need to respond with, was when it would respond with, right? And again, this is most of the questions will come in natural language, and you need to sort of understand and decipher. So a lot of the frequently asked questions, logistical questions, scheduling questions could be answered by a virtual agent, rather than expending the precious time of a full-time teaching assistant to do that. Vis-a-vis, the same person could be assigned to doing much more value-added work, thereby freeing up the bandwidth of those teaching assistants who are limited in number. So the students really didn't know about it until the end of the summer, and many in their satisfaction surveys, the bot was actually listed as one of the best teaching assistants through the summer. So that was one very interesting use case I thought will sort of bring this to fold over here. The next example is on the Watson Discovery Service. Again, this is a service that uses a combination of existing APIs. So in the picture you can see that it uses the Retrieve and Rank API, the Document Conversion APIs, the Alchemy language APIs, as well as the Alchemy News API. And what this does is, as the name suggests, right, it enables developers to quickly ingest data, right? So unstructured data could be in various forms. So going back to the beginning of the talk, when I talked about the data, right? While data is out there, how do you make really sense of the data? How do you gain insight out of that data? And that is where Watson Discovery Service can really help you out there, where you can ingest the data, enrich the data with the natural language algorithms, and then index that data. So searching, right? Searching through scores and scores of data sets, both structured and unstructured data sets, in itself is a pain, right? So using a combination of the Retrieve and Rank and the Document Conversion APIs, the Watson Discovery Service actually helps you discover, right, insights from the data that may be sitting around in multiple places. So how does this typically address a developer pain point? One, it speeds up the time it takes to extract, transform, and load the data from various disconnected sources. This could be emails, it could be chat transcripts, support tickets, news, social media, external media, so on and so forth, in a very scalable and repeatable fashion, right? So what would typically take days, weeks, months to perhaps develop, this gives developers a very easy solution to quickly prototype. It removes the infrastructure challenges associated with building something like this in-house, because most of it is done on the cloud, right? And thereby you glean complex insights, and you basically embed discovery capability into your apps, and it helps power your existing workflows and existing systems. So that's the second one I would like to leave you with. Again, there are much more details and demos and step-by-step instructions in terms of how one could actually use these services in their existing or new applications to build in conversational capability and data discovery capability into their application. Watson Discovery Service, again, some common use cases here in the domain of customer service. So you can actually augment, right, a virtual agent with the Discovery Service to provide you, to help you with actual support workflows, right? It can actually find complex answers that is embedded somewhere out in the data. Another very attractive use case is in the social media space, right? So when you have a lot of conversation happening out there in the various social channels, how do you create an app to create real-time visibility in terms of the sentiment regarding your services, your brand, your product, and thereby correlate it with other historical results? You also have a research use case here, so you could look at it to extract insight out of various industry reports, domain-specific reports, and several other different document formats, right? So again, the documents are not all going to be in structured format. You could again create an app to gain research insights. So those are again some of the use cases that can be used out there. Okay, so question distribution. So here is another example, right, in terms of the long tail and the short tail. There are certain kinds of questions which are very straightforward, or certain kind of statements which are very straightforward that can be handled by a Watson conversation. So turn on my headlights, right? It can't mean two things. Turn on my headlights is an instruction, and I could, map it to an action that turns on the headlights of my car, right? If this were embedded in my car. So, here Watson uses the reasoning strategies, focuses on the language, the context, where, when, and who is stating these words, and thereby takes action. Now, if you look at the second question on the long tail over here, it says my exhaust is making a rattling sound. How do I troubleshoot the problem, right? So this could be a series of reasons, and actions could be different depending on the context, as well as on the data that you're going to reside on or train on to reason in terms of what's next best action. So here you would ideally combine your Watson conversation service with a discovery service to identify the most appropriate action or answer. So just two simple examples between a short tail and a long tail, where a good combination of a conversation and a discovery can actually give you much more maturity in the way your cognitive system behaves. Okay, so let me now move on to a few real-life examples, right, out there in the industry, a couple, before we, close for questions, right? So here, if you look at the area of health sciences, right, and medicine, right, 90% of the data in the health space, life sciences space, is in the form of images, right? Images in the form of X-rays, scan reports, MRIs, so on and so forth, right? And understanding those images, making sense out of it, and actually providing diagnosis out of it today is largely a human-based approach, right? However, it's not always scalable, right? And let me give you an example out here, right? These are all images of samples from, possible melanoma, skin cancer cases, right? And it's one of the most common forms of cancer out there, increasing very rapidly. And if we have systems in place, right, to detect at a very early stage, right, the onset of melanoma, at scale, it's really going to drive wonders, right? So if you look at different images out here, it takes a very trained human eye, right, as well as years and years of research and analysis to actually detect the chances of melanoma, right, across these images. So we've applied Watson to some of these cases, right? And the percentage that you see here, when Watson is trained across several of those images that you saw on the previous slide, it gives you a 2% versus a 98%, right? So the 98% actually is able to highlight the chances and the probability that this could be a more, likelihood of an onset of skin cancer in this particular case versus the left-hand side. So here again, you're talking about visual recognition. You're talking about ability to understand an image and infer, and thereby, sort it against prior data, and thereby coming up with an inference. So very, very powerful application which has life-changing impact and repercussions. Another example is again closer home. This is an Indian company. Talview is in the area of HR, right? Human resources and staffing and resourcing. Talview has an intelligent hiring platform based out of Watson. So if you look at the typical hiring workflow, right, in a given organization, there are a series of steps, right, that starts from search to screen to select and then to onboarding of the individual. Today, most of those steps are done by with manual intervention, with or without a few existing tools to support the HR professionals out there. With the Talview solution, what they have done is that they've actually automated the search by using natural language processing from Watson. So the screening process, they use a series of video interviews. Again, the video interviews can be further analyzed by Watson using, say, personality insights. It's another API I didn't really talk about, where you can actually assess the personality of an individual and come up with a psychometric profile to figure if this particular psychometric profile is ideally suited for this particular role and position or not, which helps thereby in further shortlisting the candidates. Again, in the selection process, there are live interviews which can be recorded, which can be recorded for tone, recorded for intent, and then you have the regular onboarding. So Talview used a series of Watson APIs, right, and they've been pretty successful in terms of reducing the overall hiring time for their customers up to around 70%. The quality of the hire is increased dramatically, 35% increase thanks to a lot of the psychometric profiling that is being done, and thereby reducing resourcing requirements, right? So the ability to also detect attrition, detect the possibility of a candidate staying on, making the right hire, right, is also another key aspect of this, thereby reducing resourcing requirements for the future. So a lot of APIs listed out here. Each one of them is a topic on its own and deserves another 30 minutes of session. So we can always do that at a later date, but this is just to give you an introduction into what is possible today. So what next, right? So as you folks go back and try to understand this further, I really encourage you to go and explore the Watson Developer Cloud, right, which is out there. I've posted the link out here. You have trial version APIs that you can use to initially understand and learn. There are a lot of material out there. There's also a community on Slack, which is pretty active. So you could also post your questions out there in case you're getting stuck. And this is again a global community, so you will have quite a bit of participants out there in the Slack as well. So with that, I come to the end of my deck, right? And I think we're just about time to answer a few questions out here. So I've just opened up the Q&A. Okay, so let me pick up. Let me pick up something. Okay, so there's a question on how does artificial intelligence differ from augmented intelligence? So I would put it this way, right? So augmented intelligence is an outcome of artificial intelligence and cognitive, right? So AI is broadly used today, excuse me, in the context of machine learning systems and deep learning systems. What we see with cognitive is the ability to further support human beings, not just with the insight into the data that they have, but also to continuously train and teach, right? So the system continuously learns, as I said. So that in turn helps you sort of come up with systems that constantly improve with time, right? And that is where the human intelligence is very important, right? It's only as good as the human beings who are training it or the data that you're feeding it and the inferences you're gaining out of it. So that would be one aspect of it. And I have quite a few questions here. I'm just trying to sort them. What is the basic skill requirement to do programming over WDC? As I said, there are SDKs on Node, Java, and some of the other iOS languages out there. So it really does not need a lot of deep learning, machine learning expertise. The whole idea of exposing those APIs is to make it pervasive to pretty much most of the other developers out there. And I also have a question, is Siri a form of cognitive feature in iPhone? Siri, I would say, is a very basic conversational service, right? What Siri will not or does not have at the moment is the ability to understand, say, intent, the ability to understand emotion, and sometimes even the context, right? So if you remember the example that I was taking, there is a lot of intent and context to the statement that you're saying, based on which you need to come up with the answer, right? So that is somewhere where a cognitive system actually is truly differentiated, right? The ability to understand intent and to a large extent to understand tone, to understand the emotion, right? Which is very important when you're talking about systems interacting with humans. So is this free to trial on WDC or trial or paid? There is a trial version, which is, I think, for 30 days, post which there is a paid version. If you are a startup, we also have an option of getting you some free credits. So if that is something of interest, we can also look at that as part of the Global Entrepreneur Program. Contact an IBM who's focused on helping startups. Vinay, you can tweet to me. I will get you in touch with the right people. So let me just pick up, what is the chatbot feature? Is the chatbot feature in banks cognitive or plain artificial intelligence? Okay, good question, right? So a lot of the banks are offering conversational banking, right? And depends on which bank and how they're using it. Ideally, they do need to be cognitive in nature, because they're going to understand you as a customer, right? And the kind of conversation is going to be very personalized based on your context. And today, a lot of the banks are using the capabilities available out there, delving into the data and the insight they have regarding customer behavior, and offering you a very, personalized interface to do conversation. So to a large extent, yes, I would think it would be cognitive. How cognitive system growth propositions in IoT platform space. So we didn't really talk much about IoT today, Internet of Things. So there is a very strong correlation between cognitive and IoT. In fact, our IoT platform is termed Watson IoT. And there are innumerable number of use cases, right? So because IoT is all about connecting devices, connecting the sensors, and gaining insight out of that. And to give you one example, one very recent example is where we have actually, tied up with a huge automotive company to offer an interactive conversational agent in your car, right? So wherein I can talk about the weather, I can talk about, or it will continuously understand my driving habits, my driving behavior, and tune the conversation, the recommendations accordingly. So there is a lot of potential with IoT. Can Watson APIs power a social media bot and recommend products to consumers? Yes. So you could use channels such as Slack to create conversational agents, right? So if you have a Slack channel, you can use that, attach a bot to it, and use it to interact with your customers, right? So it's one of the channels. We look at it as one of the channels. So I'm trying to There are quite a few questions on banking. How the cognitive system. So conversational banking is one of them. We are working with several banking customers on further automating, say, branch operations and several others. So there are several use cases that are coming in. Why is Watson different from Infosys Mana or Wipro Homes? Okay, that's an entirely different conversation, a lengthy conversation, and happy to take that on a one-to-one basis. Because again, right, I would strongly like to state that Watson was one of the first cognitive systems to come out there in the industry. Everything else has been, pretty much post that, and it's good to see a lot of, new systems coming up in the cognitive or the AI space. Where do you see traditional programming reducing its footprint? How much of it will be still relevant in 5 years of time? Very good question. So traditional programming, as I said in one of my slides there's a lot of systems being rewritten, right? The world is going to be rewritten in code. The programming languages are changing. The way we code is changing. The coders themselves are changing, right? And hence the systems, the tools need to support, right, agile, fail fast, easy to use, easy to stand up, easy to deploy, less infrastructure requirements, and so on and so forth. So there definitely is a huge shift in the way systems are being coded. Okay, so somebody is asking me a question saying Musk is actually in arms against AI. Do you think the fears are unfounded, or is Terminator not far away? That's a fun question. Again, right, I'll go back to my statement on augmented intelligence. I don't see us being taken over by machines. Human beings are an important piece of the puzzle. They're all just going to get us to become smarter. Okay, I think with that, I should give it, I think most of the questions have been, there are several more, but we won't have time for some of the lengthier ones today. As I said, please share your feedback, and we do have a team of developer advocates, developer evangelists in IBM who can also help you out with specific queries or requirements. Please also go on to Developer Works, which has a lot of content out there. There is a learning lab out there. So if you wish to develop your skills on cognitive, there are set training paths and courses available for you to get started. So with that, I would like to end the webinar for the day, and thank you for listening, and you've been a patient audience, and thank you for all the questions. Appreciate it.
Thanks a lot, Seema, for this really empowering and motivating session today. I would also like to thank all our participants for making this webinar a great success. This webinar has been recorded, and the recording will soon be available on techgeek.com. Thank you everyone for joining us.
Thank you.